For people looking for the 1416 notes, we'll get there momentarily after we take a look at a couple of twists from 1.5. Always good to review. So as I was saying, these look normal. And I'm going along, and I get to here, and I go, I go and look to graph this, and I'm like, all right, let's see here. -2, -1, 0, 1, 2. Oops, need one more line. And I look to do these individually. Now I know with an and, most of the time, those come together in the middle. But I start to look at this and I'm like, well, wait a second. If I graph each of these separately, they're both heading the same direction. What's up with that? And you're like, you didn't talk anything about this. Remember, when it's and, it's only going to be what the two graphs have in common. So here's why that's important. Okay, this keeps going forever to the left. This, let me change colors, is also going to go forever to the left and go right through there. But we only can include in our solution what both of these have in common. Well, all of this space in here is only purple. Okay, it only helps me on this one, excuse me. But once I get to the -2, now I have my red line that was there originally, but I also have the purple one. I have both. They have something in common. So when I go to make my solution set, my graph actually won't look like this. This is where I got to be a little bit careful whenever I go to graph this stuff. Since the only place they have something in common starts at -2, the only part of the graph that I am going to graph is the part that starts at -2 and heads off to -infinity, because it's the only one that covers both. And then my interval notation for that would be -infinity to -2. It's kind of weird because it's not what we're used to seeing. It's unexpected. But if I see the word and, I have to see, what covers both of them. What do they have in common? However, another one that looks innocent, except what's different, the word in the middle, or. Okay? Or means as long as it covers either one, I'm good. So if we think of that sort of like we thought about this one up here, if I were to graph them separately, I'd be like, okay, so this one's at -2 and goes forever. This one's at 3, goes forever. But this time, they don't have to be in common. As long as it covers one or both, it's part of my solution set because of the word or. So even though they're in common here like they were on 17, all of this part where I just have red is okay as well. So when I go to do my actual graph of this one, I want more. This is not restrictive. This is very inclusive. I want all the answer I can get me some. Okay? So I want all of it, and it would be from -infinity up to 3. And the one other one I wanted to make sure we looked at, because it looks kind of strange. Well, okay, there's two I want to look at. But I want to look at another or here first. Because again, I don't like to be that guy. Tell me to do this stuff and then we never even talk about it. You're like, okay, so it's another or. One or both is good. You're like, well, what's so bad about this then? Well, let's see here. I'm going to try and do this once. X is greater than or equal to -2. Okay, so we'd be going to the right. And then x is less than or equal to 1, I'd be going to the left. So then, if that's going to happen, so does that just mean if I go to graph this, I'd be like, okay, so this is going this way, this is going this way. Is it going to be like the ands and I just color in the middle? No, because again, it includes everything. This is going to keep going right on through that bracket. And my other one going this way, because of the word or, now what they have in common, it's everything. So I'm covering everything? Yes. There is no number available that you can think of that isn't either greater than -2 or less than or equal to 1. It covers every number. Every number fits in at least one of those. And it's weird to think of it that way, but it's absolutely true. So you're like, okay, so this one's all inclusive with or. So and is restrictive. We're only looking for what we have in common. But once I see the word or in the middle, now I want every single solution that I can get. Holy cow, Harty, is there any other crazy thing you can throw at me? One more. 18's the other weird one. At least we're not having a lot of math work we're having to do. It's just kind of mentally think through. Okay, pay attention to the word in the middle. And we got to have something that's in common, something that's inclusive. All right, let's see here. Y is less than -4. Okay. And y is greater than 5. What number works for both of those? Oops, nothing. They don't overlap anywhere. They're going opposite. This looks like an or statement, but it's not. It's an and. So if there isn't any, there's no solution. There's no such thing as a number that's greater than 5 and less than -4. That doesn't make any sense. Now, do these special cases come up often? Nope. But do they every once in a while where you need to kind of be aware just in case? Sure. Okay. But I do. I apologize. I didn't get at least one of those in when we were doing the examples before. It was kind of strange. I'll get both of you here.
What is the difference between this and the one where you combine the two in the middle?
What I would do here is, let's see. Okay, let me try and figure out how. If that would have said, if this was the exact same problem and it said or in the middle, then I would just have my interval notation would have the u in the middle. And it would be -infinity to 4 union 5 to infinity. Because on or, as long as it covers one of these, I'm fine. But here, when I change the word in the middle to and, that's why this doesn't work. Because now and means whatever answer I give you has to work for everything involved, and not just that one.
All right. Now, yesterday when we were doing this, the interval notation for or ones, you told us to have two different notations with the union between them. But the way you wrote that on the board today was just one that included all of the possible ones.
Right, and the reason behind that is the way that the graph is going to look. Probably 95% of the time when you do an or statement, your graph is going to end up going out like this. And so when it splits apart, I have to use the u to be able to put those two pieces together. What happened on my two special cases here was I never had a split. I had one solid line going all the way through, and that's why I only had to have one thing written for my interval notation on both of these. The only time I got to get that u in is if I have a break that I need to be able to put together with those.
Okay.
Good question. Okay. Any other ones right now? And again, special cases. So don't get yourself into this brain rack on, this got to be a special case. Just go about it, trust your instinct, and just check, and if one pops up every once in a while, you'll be ready to go. Are there any other ones that you've done on the homework so far that you've got a question on? Like I said, you'll still have Monday to keep working too, if you haven't quite gotten that far yet. All right. So what we're going to do now for the moment, I'm going to switch gears here a little bit. Like I said, Monday with a work day, we can kind of get everybody to where they need to be and where they're at currently. But again, this guy here, again, it's getting us some examples so when we are doing the work, we got something to refer back to. Now, our first look at absolute value this year. Absolute value, concept you've been probably working with since pre-algebra even, just describes itself as a distance from 0 on the number line. Okay? It's always positive or 0 because when you think about distance, I always think about driving a car. So when you're going in the car, okay, the odometer keeps going up as you drive more miles. When you drive to your friend's house or then drive back, or drive anywhere and drive back, it doesn't reverse itself when you're going the other direction. It keeps moving forward like a positive number would. So for instance, if you're asked to find the absolute value of x and they give you a number, they're asking you what two numbers are, could be going here where you have a distance from 0 and get to 5. Well, just like it did here with this one, I could go 5 to the right and I'd be 5 away from 0. I could also go 5 to the left and be 5 away from 0. But the value itself, okay, is still positive because it's a distance. And like we note here, what's inside can still be positive or negative, but once it comes out of those bars, it has to be a positive value. So let's kind of watch this because this whole positive and negative thing can get to be a little bit of an issue with these. All right, so we have an equation. The absolute value at 2x minus 5 equals 9. We're always going to split these into two equations, okay? That is never going to change. So you'll notice, you're like, okay, now what's different between these? The first one looks just like the original, except I dropped the absolute value bars. What's different about the second equation from the first one? One little thing. Yeah. What I'm going to basically do is I'm going to split this into two equations. The left side stays the same, but I'm going to switch the sign on whatever my value was here. So 9 becomes negative 9. Let me show you why that is. When I go ahead and solve these and get my two values for x, and typically you're going to end up with two answers for these. Add my 5 over, be really careful. These are the two values that I could plug in for x and get an answer out of them at the end that's positive 9. So for instance, 2 times 7 is 14, minus 5 is 9. The absolute value of 9 is 9. Good deal. 2 times negative 2 is negative 4. Minus 5 is negative 9, but remember, it's always going to come out positive. So the absolute value of negative 9, or its distance from 0, is positive 9. I get my two answers. I'm good to go. I'm done. Now, I'll just give you a heads up. Sometimes, whether it's a book or somewhere else, instead of just writing them like this, they may use what's called a brace and put the solution in braces like this. I'm not going to get that picky, but just in case you see it sometime and you're like, what are those things? Okay, they're braces. It's just a way of saying it's not a distance between. It's not like interval notation where I'm saying it's all these numbers. It's just those two numbers. I get the answer. Okay. So equations, we just flip that. Inequalities, we get an extra little part in here. So there's going to be two pieces to this. Okay. When I get to my second equation, or my second inequality, excuse me in this case, number 1, I'm going to flip the arrow. I'm going to flip the inequality arrow. And 2, I'm going to switch what I call the answer sign. That's sort of what we did here. We turned 9 into negative 9. Here, there's two things I'm changing. I'm changing the arrow, and I'm changing the value of my last number. That's always going to be the same with inequalities. Flip the arrow, change the sign. Otherwise, just solve them. Okay? But here's the other kicker you start to notice. You're like, uh-oh. Notice here, my absolute value is less than. Whenever that occurs, we assume it's an and statement. They won't tell you that it's and. Okay, that's something we're going to have to know. If it's greater than my absolute value, it's an or statement. And I'll keep talking through that on all of these just so we get used to that a little bit more. But otherwise, I'm just going to solve each of these inequalities separately. And again, don't get in such a rush that you get yourself into an issue here. So I get my 2. Now I remember with and normally I've got my 2 endpoints and they meet in the middle. So we'll see if that happens. But I do need to get myself some numbers here, don't I? And you're like, ooh, I can even skip some if I want to. As long as you're consistent, if you don't want to jam them all in with your numbers, you can spread them out more. You can do fewer numbers more as long as you have 3. That's all I care. And then I'm going to go ahead. I've got x is less than 2. Okay, so that would be this. And we'd be going to the left because less than goes to the left. And then x is greater than -9. Okay, and there's -9. Okay, yep, just like I thought. Now, this is not going straight through. Because remember, that was an or statement when it went through. And what do we have in common? Well, whatever's in between us here. And once I have that, my interval notation just works from left to right. So there's a lot of similarities for what we were doing with the inequalities. It's just a little bit of a change in how we set up the initial problem and what we think the graph's going to look like at the end. Same deal going on with C. I'm going to add my 2 over. Oh, gee, Harty, what do I do when I get a fraction here? You know, improper, mixed, decimal. I don't care. The one thing, since we're making number lines, in this case, it would probably be easier for some of you to go to either a decimal or a fraction, and I don't care. I don't care if you go to 3 1/3. I don't care if you go to 3.33. Okay? I'm going to live with that. And then I'll get my other one solved as well. Always going to have 2 inequalities to work with on these. So I start looking. Now I really don't want to do these by thirds. I'm sticking with whole numbers. So let's see here. That's good enough. And again, if you want to count by 2s or 3s or something, that's fine too. So I'm like, all right, let's see here. Now I know or. Or typically starts going out with the graphs. They split from each other. So let's see if that happens. So x is greater than or equal to 3 1/3. Okay, so a little more than 3. That's heading off this way. And then x is less than or equal to -2. A less than goes left. Yep, they're splitting. Okay, that's good. And or means that's okay, because as long as it covers one or the other, we're fine. This is the big, long interval notation. The one that starts to the very left of our graph at -infinity and comes up to our first stopping point at -2. And then we're going to lock that up with where our other one starts, at 3 1/3 or 10/3 or however you wrote it. And off forever to the right we go. But again, the key here is going to be, bless you, remembering if it's an and or an or. Because that's kind of important. So let's just make sure. Number 10, before we ever do anything else. Is this an and or an or? It's an or because it's my absolute value is greater than. Okay, so we know this is an or. And that gives us some hints on some things, on the interval notation and what the graph should look like. So let's break this up. First time, I just basically recopy what I see, just don't have the absolute value bars. And then again, on the second one, switch the arrow, switch the sign. Got to do both. If I don't do both, I'm in big trouble. And then solve them. And again, the only time we're going to consider flipping the arrow is if we're dividing or multiplying by a negative number at the end. Not just because I see one there. It's got to be all the way through for me to have to do that. Alright, so we got an or. We're thinking they're going to move apart from each other. Let's see if that happens here. This is going to get a little bit crowded, but that's alright. Alright, let's see. X is greater than negative 2. So then go to the right. X is less than negative 3. Okay, that looks about right. Looks normal. And then again, my interval notation, when I have that gap, I've got to lock these two together. So my red one starts at negative infinity and goes to negative 3. And we're going to lock that up with our second inequality that starts at negative 2 and goes off to infinity. But again, the little details can pop in here. And you really do have to be careful for not letting one of those little parts get to you. For instance, I look at this last one on the front here and I'm like, all right, is this one an and or an or?
Or.
Another or. All right, so we know these are probably going to split from each other. So let's see here. 2x plus 3 is greater than or equal to 11. Keep what's in the bars the same, but switcheroo the arrow, switcheroo the sign. And then we're just going to take a minute here. Get those in there. Let's see, is this looking good? Less than negative? Yep, this is looking good. Okay. Let's see. Count by 2's this time. Make it fit a little nicer for me. And I go, okay. Greater than 4. Looks good. Less than or equal to negative 7. Looks good. Looks good all around. But again, the key is going to be recognizing what type it's going to be. I think I got one more regular one I want to do, and then we will get you set here. So just a reminder as we start to move to the back. because you'll get rolling along so much with all these interval notations, you'll get back to the equation and go, wait a minute, how's that work again? Remember, when you're doing the equations, leave it alone the first time, and the only thing that changes the second time is that I change my solution to the negative. There won't be graphing, there won't be interval notation, there's nothing to interval notate here. Just trying to get my two values and I'm content. So just use things otherwise as a little bit of a hint. And then the last possible twist, because I'm not giving no more twists. Just, So as I get up here a little bit further, I'm like, okay, generalization. Let's explain it instead of actually just pondering it here. So I look and I go, okay, I must isolate before solving. Okay, sounds good. Basically, it just is saying, let's get this out of here. And once I get that out of there, I can actually go through and try to do this. So once I get here, it's just an equation. And I'm going to split it into two parts. Again, only thing changing is my solution part. Add my 3. Add my 3. Happy camper. You're like, good. Doesn't sound like there's any more weird things going to happen. Uh-oh. Yeah, there might be one. So here's going to be my last thing I throw at you. And I'm actually going to save this writing absolute value inequalities. At the very start will be the only thing we have to do besides for the workday on Monday. Ooh, double stars. What's going on with double stars? Okay, we talked before about how absolute values can only take on two values, 0 or a positive number. Okay, so if I do the absolute value here, is a positive number greater than negative 13? Yes. Is 0 greater than negative 13? Yes. Is there any possible way I could pull a number out of here that will not be greater than negative 13? No. So if you see a negative number on the opposite side of one of your absolute value equations or inequalities, there's not going to be much work to do because it's going to be one of two things going on. This is always true because this is always 0 or a positive number. So if this statement's always true, that means every single possible number I can dream up is going to be in the solution, which means my interval notation would be negative infinity to positive infinity. Everything works. We like it when this happens. You're like, well, couldn't I go ahead and do it and just change that to 13 with negative? You won't get all the answers if you try going that way, or it might even confuse you a bit. This one's just the opposite, which is why they're right next to each other. Again, if this is 0 or positive, well, 0 isn't less than negative 2. Any positive number you come up with isn't less than negative 2. This is never true. There's no number I can plug in. There's no solution or empty set. So that's the only weirdness left that I can throw at you with this. So what this will do is it will give you a chance as you're starting to look through some of these. And like I said, this last part, there's a little bit more to, so I don't want to fire one last part here. When you start to work on the practice, okay, you're now capable of everything on here. The only place that you will possibly get stuck is this one little part in with the bookwork. But again, we got all the time Monday to be working on that. And we even threw a few review things back. Hey, looky. Equations and fractions. Think of that. So, plenty of time. Get a little bit of a start over the weekend. Monday, we can answer some original questions, finish off that little bit, and you'll have some work day to work with.